Welcome to Chapter 3 Lecture Part 1. In Chapter 3, we're going to talk about the electronic structure of atoms and the periodic properties that are found in the periodic table. That's why it's called periodic table. Your reading assignment, is going to be sections 3.2 through 3.7. Here's the outline. We're going to actually do a little bit of a switch here. We're going to start with the periodic table, so section 3.5, and then move through 3.2 through 3.4, and then the last two, points 6 and 7. So let's first talk about the periodic table, how it's organized, and how we group things together. It's a very useful tool. The periodic table is section 3.5. This is a modern periodic table where you have all of the elements listed and you have a symbol for all the elements. Now, some tables are a little more elaborate and some less so, but all of the periodic tables, however simple they might be, they will at least have these three things. They will have the symbol of the element. They will have the atomic number above that element. Some have it right above, some to the left, but we'll have the atomic number. And then at the bottom of the symbol, we'll have the atomic mass. And we've talked extensively about the atomic number and the atomic mass. This is number of protons. This is protons plus neutrons. The atomic mass gives me the mass of one atom, but I could also use this, as we learned in chapter 2. I could use this number as the molar mass, meaning the mass of 1 mole of hydrogen atoms. They're used interchangeably. Some tables will also have the name of the element spelled out, and some don't. You will be responsible for learning, and I have posted a page, a Word document that tells you what I expect you to know out of the periodic table. So please do so. Learn the symbol and the name of each atom. Think of this, the periodic table is our alphabet in chemistry. Just like we use the alphabet in a language to learn to make words and form sentences, we use the periodic table and the symbols that are found here to make compounds, which are words, and then compounds react together to give us chemical reactions, and that will be our sentences. So therefore, learn the symbols very well. You will have a list of all the elements that I want you to learn from the periodic table, as well as the polyatomic ions, which you need to know very well as well. So let's look at other divisions of the periodic table. So all of them will have, this is a simpler one, we'll have, here's the atomic number, here's the element symbol, here's the mass number underneath, and then the name. Now, the periodic table is organized into columns and rows. Every row is called a period. So the rows are called a period, and the columns are called groups. These will be very handy when we figure out how to do, specifically later on when we figure out the ions, how to figure out ions, how to fill out electronic shells, how to do electronic configuration, etc., etc. But the rows are called periods and the columns are called groups. In groups, interestingly enough, you'll find that, except for hydrogen, because it really should belong over here, but in groups, what you will find is that the elements are organized by similarity. And we also call them groups or families. For example, the first group here is the alkali metals. These metals are very, very reactive. And we group them, so we group elements in groups according to similar characteristics. They have similar characteristics, similar reactivities. So all of these chemicals, all of these atoms react the same, very similar to each other, and therefore they're grouped in one family. The next group over here is group 2, so this would be 1, this would be group 2. We call this the alkaline metals, and they react very similarly. They're slightly different from this group, but they are all very similar to each other, and therefore they're grouped under the same family, etc., etc. So as I said, this is the alkali metals. The next one will be the alkaline earth metals. That's the name for this group 2. Group 1 is alkali, group 2 is alkaline earth metals. Now we skip this one when we count. Some do and some don't. Some periodic tables do and some don't, but I learned it this way, where I used group 1, group 2, then we skipped to group 3, 4, 5, 6, 7, and 8. We kind of skipped this middle part here. But let's talk about this next group. So we talked about alkali metals, alkaline earth metals, and then the next one, group 7 over here, they're called the halogens. These are very reactive as well, and they are so next to the last group in the periodic table. Oops, I went backwards. And then the last group, these are called the noble gases. They're called the noble gases because they do not like to react very well. They're very noble. They don't like to mix. And so these are called the noble gases. We will talk about why they are important in the chemistry and why every other element is trying to get to the same configuration as these elements here. But they're called the noble gases because they do not like to react with other elements. They stand by themselves, they stand aloof, and so they're called noble gases. Next are the transition elements. These transition, and this chunk here that we skipped when we were numbering, so group 1, 2, 3, 4, 5, 6, 7, and 8, we skipped this one. However, some tables they don't. They'll just 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. They'll add these 10, but for simplicity, we can skip the counting here and just do 3 instead of 13. If you count these, this will be 13. If you don't count these, this starts at 3. So 3 through 8 or 13 through 18 is the same idea. But this chunk here is called the transition elements. And I call these the unruly children. They are they're predictable, but not as predictable as the other elements that we're going to talk about in these other groups. And so they sometimes behave in one way and sometimes in another. And we're going to learn how to figure these out. But this group is called the transition elements, and you should know that this division here are the transition elements. Then the next chunk down here is called the inner transition elements. These groups should really fit right in between these two. So if you see lanthanum here and hafnium over here, go from 57 to 72. That's because we need to fit 58 through 71 right in between these two. And then actinium here, between actinium and rutherfordium, 89 and 104, we should have this row over here. However, this would kind of make our periodic table a little interesting, and so we've dropped these down to kind of organize these better. Now, some periodic tables are not organized this way. They're organized in a shell model, and we'll look at it when we figure out how to do ions, but most of the periodic tables are organized this way. So this is why these are called the inner transition elements, because they belong inside here, but we're dropping them down to just make the periodic table a little more manageable. Then the last group over here, the last chunk, has no common names. This is just group 3, 4, 5, 6. They don't really have a name like the other ones that we were talking about. There are also other divisions in the periodic table. The largest number of elements in the periodic table are called metals. Metals have different characteristics than the other groups of elements. They are shiny. A lot of them are gray, although there's some that would have a different color. They are solids, typically at room temperature, although mercury appears as a liquid, but most of them are solids at room temperature. They're very reactive with oxygen. They form oxides very easily. They react with water to form hydroxides, etc. They conduct very well, conduct our electricity very, very well. They're ductile, which means you can pull them into very, very, very thin wires. You could pound them into very thin sheets. Aluminum, for example, makes aluminum foil. It could even be pounded into smaller size than the aluminum foil that we have. I mean, we have two sizes. We have a regular and a heavy duty, right? The heavy duty is a little thicker than the regular size aluminum foil. These are the characteristics of the metals. They melt at very, very high temperatures, and they boil at even higher temperatures than melting. So those are some of the characteristics of the metals, and they're very conductive. I said that. Most of the periodic table then is a metal, and these are found in the left-hand corner, upper and lower left-hand corner of the periodic table. And then we have this little line of atoms, or right here, these elements right here that separate this group from that group. So starting from the first element in group 3, and then we have 2, 2, 2, and then 1 over here in group 7. These are called metalloids. In some places you might see them as semi-metals. They are the boundary between these two groups. So they have certain characteristics of this group and certain characteristics of that group. And therefore they're not quite, they sometimes have metallic properties and some non-metal properties as well. So these are in between the two groups. And we use these a lot in technology, such as when we make computer chips or for your phones or tablets, etc., etc. We use some of these, and we use silicon a lot because it's ubiquitous, it's found everywhere, and it's cheap, etc. But some of these other ones are even better than silicon in technology, but we use silicon because it's very cheap. But they're semiconductors. They're not full conductors. They don't conduct as well as metals, but they conduct better than the nonmetals. And we can actually dictate how they conduct, and that is what allows us to use them in chips, etc. And then the last group are called the nonmetals. Note that the hydrogen belongs to the nonmetal category, even though it's placed here with group 1. It should really be over here by the fluorine. However, it's a nonmetal. Nonmetals are the smallest group, well, other than the semimetals, but they're really small compared to the metals, and they're on the upper right-hand corner of the periodic table. Their characteristics are complete opposite to the metals. They're not very good conductors. Most of them are gases in room temperature, except for bromine is a liquid. They're gases, and most of them. Very few are solids, like carbon, for example. And they don't conduct very well. Because they're gases, you cannot really stretch them, make anything with them, because they're not solids. They are, a lot of times they don't have, they're gases, so they don't have a color other than bromine. Some of the halogens, but they don't have a color, they don't have, um, so their physical characteristics are just very different, the opposite of the metals. They're very important though, because even though they're few, they pair up with a lot of our metals and form a lot of the salts that we use um, as chemicals. So these are the three divisions of the actual, not necessarily by groups or periods, but these are the divisions of the actual atoms or elements. So we have the metals, which is the largest group, the nonmetals, or the semi-metals over here, and then the nonmetals to the upper right-hand corner. The main groups that we will deal with are these group 1, 2, 3, 4, 5, 6, 7, and 8. So these are going to be the main elements that we're going to deal with. We're going to have a few here, and then when we talk about radioactivity in chapter 20, we will have a few over here, but not that many. Most of the elements that we're going to deal with are these, and they're called the main group elements. So this is the overview of the periodic table and the division of the periodic table. And we will stop here for part 1, and we will continue with Bohr's atomic model and electronic structure in part 2 of the lecture.